This physics engine is now able to handle collisions between convex polygons, and I want to use that feature for implementing games. So I wrote a list for what needs to be done in order to make that process more convenient, and I'm going to go through that list step by step. In this episode, I will make smaller changes on this engine to make it more user-friendly. I'm going to start with the issue that bothers me the most, and that's that the body objects don't have their own position and angle properties. In the reposition method, I change the position of the first component, and the position of the other components are calculated based on that. So I cannot directly change the object's position and angle, only of the first component, which can be really confusing. So first I check the canvas, and I can see the 10 random objects moving, colliding, and rotating. And I'm going to introduce the new properties step by step, starting with the simplest one, which is the ball object. So I comment out all the other objects in the main loop, and I will test for only balls first. Up in the ball class, I set the position property in the constructor to x and y, and in the reposition, instead of changing the position of the first component by the velocity vector, I change the position of the ball itself, and then the first component will get its values from the ball's position property. And I go to the penetration resolution function, which is the only place where the object's position gets directly modified, and I can delete the reference to the first component from there. And that's all I need to do with the ball class. So I can go and test it. There are the balls there, and they are working properly. Then I move on to the box class. The position property will be the coordinates of the central point, and that gets calculated in the constructor of the rectangle class. So all I need to do is copy that value in the constructor to get the initial property values of the box class. Then I use the same change for the linear velocity as I did in the ball class. And as for the angle property, the body class still doesn't have one. So I go up and create it, setting the default value to 0. And then I go back to the box class and I change the angle property in the reposition method. The getVertices method of the rectangle component will get this angle as an argument and use it for the rotation matrix to get the vertex coordinates. And if everything went well, then I can go down and uncomment the creation of the box objects, and now I can see the boxes and the balls. They are both working okay. The main difference between the box and the capsule classes is that the capsule consists of multiple components. The initial value of the position will be the central point of the rectangle component. Then in the reposition method, the position and the angle will be modified the same way as in the box class. And after the first component gets the new direction unit vector, which happens here in the getVertices method, the positions of the other two components will be calculated based on that. And again, I can go and uncomment the capsule creation part in the main loop and see if everything is still working. Okay, it looks good. And after all these, handling the star class won't include anything brand new. Both of the triangle components will get the star class position, and both of their getVertices methods will use the same angle value. And of course, I need to provide an initial value in the constructor as well. And again, I don't need to bother with calculating the triangle's central point because that's already done in the constructor of the triangle class. And if I uncomment the last section in the main loop, then I should see that everything works just like a few minutes ago. The difference is that now I can directly change the body object's position and angle. And I define a position value for the wall class as well. It will be the middle point. Right now it doesn't matter, but it can be useful during the upcoming improvements. Next, I'm going to make some changes in the methods of the body class, like introducing the super keyword and adding 3 new methods. Right now, the methods of the body class's children are very similar to each other. The draw method iterates through the components and calls their own draw methods. The key control has 4 if statements with the same conditions, And the reposition calculates the position from the acceleration and the angle from the angular velocity. I can take the parts that are the same in each of the objects and put them in the parent class. For example, in the reposition, I can cut the calculation of the position and the angle and paste it in the reposition method of the parent class, the body. And it works the same way for each of the children classes. So I can do it for each of those. And then I call the parent classes method with the super keyword on the top of the children's method and add the extra lines to each after that. And once I've finished iterating through the reposition methods, I can do something similar with the draw method. Actually, I renamed this method to render because its job is to render the body object, and calling both of these methods draw is not a good choice. So this render method iterates through the components, calling the draw method of each one, so that the whole body object will be displayed on the canvas. And that's all. I only need to call this parents method in the children's render methods. And although the key control methods are also very similar to each other, I decided to keep them as they are to be more flexible about how the up, down, left, and right variables modify the state of the object. And I quickly check the canvas again, hoping that everything still works the same way. And luckily, that seems to be the case. I also get rid of the display method. It was useful earlier, but I'm not going to use it in the future. And I also don't actually need to call the render method of the children classes if they are exactly the same as the parents render method, because that's what inheritance is for. So I delete all the render methods in the child classes, and then I can move on to the next item of this to-do list. I think there is an important method that should be added, and that's deleting an existing object. Now, all the objects are collected in the bodies array. They are pushed into it in their constructor, but right now there is no way to remove them from it. So for example, if an enemy dies or whatever in a game and there is no need for it anymore, I can call a method called remove. And all it does is it takes out an object from the bodies array using the splice method that can remove elements from an array, starting from the array index of the object itself. I will test this by calling it for every star object in the main loop at the moment they are created. So now they are there, and I remove them immediately, and now they are not there. The next step for now would be adding new properties to the body class. The first property I'm going to add is the friction, or actually two, the linear and the angular ones. Right now I use the linear friction as a global variable so that every body object is using the same value. I can delete the function variable from the global scope and add it to the body class, and in the reposition method I use the this keyword for changing the values of the velocity vector. Then I add another property to the body class, the angular friction, and I multiply the value of the angular velocity by 1 minus angular friction in every frame, so that if the angular friction is 0, the body object keeps rotating with the same speed. I will test that on capsule objects. So in the main loop, I comment out the creation of all objects except for the capsule, and I set the linear friction to 0.05 and the angular friction to 0. Then the capsule will keep rotating all the time. So the friction property is working. From the next two variables, I'm already using the one called acceleration, and its value is set to 1. But I want to rename it because it is only the acceleration caused by the user's keyboard, and later, when there will be multiple forces, it won't be the only acceleration source anymore. So I rename it to key force. The larger its value is, the faster the objects will move once an arrow key is pressed. I need to rename it in the body class and in each of the key control methods. And similar to the angular key force, which is set to 0.1, like here or here. Also, if the value is large, then the object will start to rotate faster if a key is pressed. So the new property will be called angular key force, or ang key force. And I also introduce a maximum speed property, which sets the magnitude of the velocity vector to a specific value if it happens to be larger than that, except if the max speed property is set to 0, because in that case there won't be any speed limit. So I can set it to 3, and then no matter how hard I'm pushing the arrow keys, the ball object's velocity magnitude will never exceed that specific value. And I also want the left, up, right and down variables, which here are now global variables. I also want to use them as object properties. Their values will change whenever a key is pressed, and I will add a fifth one that I will call action for the case the player is supposed to do anything else than moving. And of course later there can be other keys added. So this means that the user input will get an object as argument, and the properties of that object will be changed. And I add an extra condition for the action property that will be triggered for the space key, which has the key code of 32. And down below, where I'm calling the user input function, I give the player ball as an argument to it. Plus, I also need to change all the conditions in the key control methods. And then I'm going to write a method that will change the position and angle values not only of the body object, but also of its components. Originally, I was planning to write two separate methods, one for setting the position and one for setting the angle, but then I decided to merge those two into one method, using the so-called default parameter for the angle property, which according to the MDM WebDocs website allows named parameters to be initialized with default values if no value or undefined is passed. This method will be similar for each of the body classes, but still different enough to go through each of them separately. I will start with the capsule. I create a setPosition method where the third argument has a default parameter, which is set to the object's angle property. And I take some of the lines from the preposition method. So first I set the position vector to x and y, then get the first component's position, its vertices and its direction vector. Then I get the position of the other two components, and since those are circles, I don't need to calculate their vertices. And finally I change the value of the angle property based on the angular velocity, just like I did before. At the end I can just call this setPosition method inside of the reposition, where the positions parameter will be the one with the velocity vector added to it, and I leave the third argument at default. So that's it. With the setPosition method I can reposition a whole capsule object without actually calling the reposition method, while I can also use it inside of the reposition method. And I can go through the other three classes, the star, the box and the ball. The idea is always the same. The difference will be in finding the position and vertex values of the body object's components. So this means that if I call the setPosition method for an object, it can be rendered with its position method on a given point without calling the reposition. And I can also define its angle property if I want its orientation to be different. For testing, I go down and I place all the balls at 100, 100, the boxes at 200, 200, the capsules at 300, 300, and the stars at 400, 400. The penetration resolution should take them apart from each other whenever they are overlapping. And I can see that it's almost good, except that the ball objects don't seem to be pushed apart. The reason for that lies in the findAxis function in the separating axis theorem. If the circle's central points are exactly the same, then the separating axis direction, which is calculated by the difference of their position vectors, will be 0, 0, and in that case the collision can't be detected. So I write a condition that in this case, which is by the way can only occur by setting the positions manually, the separating axis instead of the distance vector will be a random unit vector. And if I check the canvas again, I can see that the circles or the balls are now separated. Okay, now here are the rest of the items of the to-do list I wrote for this episode. Next I want to have the opportunity to paint the objects with a given color. So I create a color property in the body class, set it to empty as default, and pass it as a parameter to the components draw methods inside of the render. And I use that parameter in the draw methods so that if the color is empty, then I will use a black stroke that will make them look the same as they have looked so far. And if the color has a value, then I'm going to use it for the fill style. And I use exactly the same method for all the draw methods, except for the line class, which is just a line. So I use stroke there instead of fill. As for testing, I set the balls to red, the boxes to blue, the capsules to light green, and the stars to yellow. And I can use the hex code for the color as well, so I try this hashtag 5B2C6F in apostrophes for the player, and it will be dark purple. Or at least I would call this dark purple. And now that things look prettier than before, I start to focus on some structural changes. If I go to the main loop, I see that the only role of the separating axis theorem, which is responsible for the collision detection, is to provide details for the collision handling. But what if I want to detect the collision but have another kind of response to it instead of changing the velocity vectors, like giving a score for the player or something like that? That's why I will take out the collision detection function from the main loop so that I can use it separately. And it will get two objects as parameters, and it will return false if they are not overlapping, but still return with the collision parameters if they do, so that the collision response will still work if needed. I delete this collision display line, and then in the main loop, which I renamed to physics loop because that's its purpose, I use this collide function as a condition. If it's not false, then the return values will be equal to the variable called best SAT, which is the same as before. And those details will be pushed into the collisions array. And this is a good opportunity to introduce one last property for the body object, the so-called layer. Two objects will only collide with each other if they are in the same layer, or in other words, if their layer properties have the same value. The only exception is 0, because objects with the layer of 0 will always collide with everything. For applying this, all I need to change is the condition for when to put an object pair into the collisions array. If they are colliding and their layer properties have the same value, or at least one of them has the layer value of 0, that's when the two objects will be pushed into the collisions array. And I test it, set the layer to 1 for the ball, 2 for the box, 3 for the capsule, 4 for the star. I won't change it for the player and also not for the walls, so that they will get the default value of 0. And I can see that the collision response only happens between the same objects, while the player collides with all of them. And it's important to notice that the collision detection still works for each object pairs, it just doesn't have the consequence of simulating the change of their velocities. In this long condition here, it's better to put the collision detection at the end, because that is the most compute intensive part. So if the layer condition is not true, then it won't bother going through the separating axis theorem. And this way the engine will be a little bit faster. The next change is a smaller one. I want to keep this put walls around canvas function, but I want to put walls not just around the canvas, but around any axis-aligned rectangle. So I rewrite the arguments a little bit. The function will take the top left and bottom right corner coordinates of the area to put walls around. And then down below, I can call the function with these arguments. The last larger milestone will be separating the 4 loop steps from each other. And I will use this familiar picture for reference. I will have a user interaction, a game logic, a physics engine, and a render block. First, I'm going to create the render part. This will be a function that clears the canvas, then iterates through the bodies array, and renders each object. And at the end, it will look like this. The user interaction will be similar. It will be a function called user interaction that calls the key control method of the body object with the player property set to true. The game loop will be the function called game logic. I will just create that function, but I leave it blank. So whenever I want to repeat something in every frame for the game, I can define that in this function. And the last block will be the physics loop that will include everything that's left in this main loop function, the reposition, the collision detection, and the collision resolution. I only delete the request animation frame from the bottom, and I rename it to physics loop. And to combine these 4 blocks, the user interaction, the game logic, the physics loop, and the render here, I create a new main loop function, call these 4 functions after each other, and include a request animation frame at the end. And since I'm already calling the main loop in the very last line, I don't need to change anything else. The program will work just like before, but by using separate building blocks. Plus, I also create a function that only calls the render loop and none of the other building blocks. Its name will be render only. I'm not going to use it right now, but it will be useful later. And I'm almost done with what I was planning to do in this episode. One last change is that I put the user input function in a separate file called userinput.js, just because it will be probably different for every game, so it will be easier to reach it when it's stored in a separate file. And it can be also augmented later by mouse events or things like that. And that also means that I need to create a reference to the new JavaScript file in the index.html after the physics engine, since it's using the variables that have been defined there. And now, after all these, it's time to go through the creation of a game using this engine. First, I create a game.js file and write a reference to it in the index.html after the user input. And I will define the rendering context there instead of the script.js. So I cut and paste the first two lines. And I do exactly the same with the last two lines, where I call the user input function and the request animation frame main loop. So I cut and paste those two lines and those go to the bottom. The games will consist of two stages. In the first one, I can create the objects, set their starting properties, make them ready to start. And in the second half, I define the game logic. Whatever is inside of that, it will be checked for every frame. And these two lines at the end are responsible for handling the user inputs and running the game loop. So basically, this is how the template for a blank game would look like. And I demonstrate it with a simple example too. It will be based on these previous 10 random objects. I can cut all these lines from the engine and paste them in the first half of the template, since it's all just setting up the objects without including any game logic. And if I leave it like that, without adding any kind of game logic, then everything will work just like it did before. To include some game logic, I create a random objects array on the top, and I push all these random objects in it whenever they are created. And I give them a random vector to initialize their velocities, but I make sure that it's only if their mass is not 0, because I don't want the objects with 0 mass to move. Then in the game logic function, I iterate through this array, check if any of them is colliding with the player, and if that's the case, then the player loses and gets removed. Okay, for some reason all the objects got removed. And to see why, I go to the remove method in the body object. If an object is not in the array, the index of it will be -1. And after I get rid of the player, the splice function still seems to be working. It looks like it deletes an element from the -1st spot. And that starts a chain reaction that results all the objects being deleted. I need a condition to make sure that the splice won't work for the elements with the index of -1. And if I check it again, now I can see that it does what I wanted it to do. And if I want the other objects to disappear instead of the player, I can call the remove method on them, and it will work too. It will only remove them from the bodies array. If I want to remove from the random objects array as well, I need to call the splice method. And later I can set a winning condition, keep track of the player's score, things like that. Something I forgot to change is that inside of the user interaction function, I don't need to check the value of the player property anymore, because the user input function, which I just put in a separate file, and which will be called in the game.js file, takes the player as an argument anyway. So I will call the key control function for all of the objects, even if almost all of their left, up, right and down properties will be false for now. And I make a little change in the render only function. I copied all the lines of the render loop function into the render only. Instead of that, I can just call that function there. So this was my to-do list after playing around with the physics engine for a while. I surely missed many things, but I think that the engine is better now than it was before. I will put this example game that I just wrote on GitHub and also the empty game template. And I will keep working on the physics engine sometime in the future.